where the forces of nature meet. In a hidden world, a tropical miracle. At this moment, evolution is building a living colossus, a giant built by nature's tiniest creature, a model of reincarnation, a survivor born from disaster. The Great Barrier Reef. The world's largest structure isn't man-made. Nature built it. A coral reef, half the size of Texas. A living jewel off the coast of Australia, so large it can be seen from space. And within it, a vast aquarium like none on Earth. No other waters are more diverse. Of fish alone, experts have identified 1,500 species, and counting. The Great Barrier Reef is a gallery for beauty, a showcase of the unique, a refuge for the endangered, one of the planet's last paradises. To understand it takes a new breed of scientist, one willing to go to extremes to get answers. The reef is a mystery that can't be solved in the lab. To crack it, you have to live it. Beauty swims with violence. Fish here have the shortest life expectancy on the planet, yet the reef is an orchestra of the living. Where every plant and animal helps sustain the whole. The waste from parrotfish cements the reef. Stinging anemones provide a haven to the vulnerable. Even killers play their part, preventing a population explosion that would destroy this fragile ecosystem. Life doesn't just reside here. The reef itself is built by one of its smallest tenants. For more than 15 years, marine scientist Dave Wackenfeld has been coming down here to study coral polyps. These tiny creatures are closely related to jellyfish, but much smaller. They don't have a bone in their body, yet for 500 million years, they've been nature's greatest builders, architects of labyrinths of limestone.
Soft corals, we can see the hundreds of tiny polyps.
Every bit of this reef has had an odyssey to get here. The coral starts out life as larvae, floating free in the ocean. For each one, the chances of survival are slim. They have to run the gauntlet of 1 million hungry mouths as they cross up to 1,000 miles of open ocean. Fewer than 1 in 100,000 complete the journey, and then they're faced with a second hurdle, finding the perfect landing site. Falling on sand or a crowded outcrop is death. Those precious few that survive will start a colony. Once settled, the larvae begin to grow. Transforming into adults called polyps, they develop tentacles that can grab food from the water. As a polyp grows, it puts up a wall of limestone around itself, and then it multiplies. Each polyp can produce thousands of offspring, which all work together to build a living fortress, a coral reef. After just a few years, a single piece of coral can harbor as many as 25,000 polyps, all children of the original founder. These creatures live fast, but not all die young.
Many corals that help to build the reef only live for a few years, but some, as individual animals, will live for 1,000 years or more. These animals are as ancient as any plant or animal on our planet. They're quite incredible.
Here, the polyps have gone into overdrive. They have built a reef over 1,200 miles long, enough to stretch from Seattle to Los Angeles. Because in this one spot, a unique combination of circumstances have come together to create a coral heaven. The whole reef sits on the barely submerged edge of the Australian coast, known as the continental shelf. Other continents have shelves, but none like this. It's huge, in some places up to 100 miles wide. On this shelf, it's summer all year round. Most of all, it's shallow. So this whole stretch of seabed is blasted in sunlight. To polyps, light matters as much as warmth, because living within its tissues is a plant. Inside the flesh of these tiny animals are microscopic plants called algae. But these aren't parasites. None of this would be here without them.
When the algae photosynthesize, they take energy from sunlight and carbon dioxide. They make sugars, which help to supply energy to the coral.
It's one of nature's perfect partnerships. By capturing the energy from sunlight, the algae supercharges the coral, providing it with up to 20 times more energy, fueling the rapid growth of the reef. When the first coral arrived on Australia's east coast, they'd found the best place on Earth to make a home. One huge, shallow sun trap. Trillions followed in the biggest construction project the world has ever seen, exploiting every piece of real estate. Right up to the very edge of the continent, where the seabed plunges into the abyss. Today, it may look like paradise, but hidden deep beneath the waves lies one of its most brutal and violent secrets. The Great Barrier Reef seems idyllic, life in perfect harmony, bathing in warm water all year round. But in the past, this paradise has gone through hell. Scientists now believe that it has endured massive catastrophes that wiped out the reef, almost stripping it of life. Catastrophes that traumatized the entire planet. Scientists are only just beginning to uncover the whole truth. On the outer edge of the reef, there is evidence of an anomaly. It looks like another reef, but it's 190 feet below the surface, where no reef can survive. No one has ever sampled it. Geologist Jody Webster is about to be the first. But these are dangerous waters.
Shows it really quite well.
In order to bring back a piece of this mystery, His team of divers will be risking their lives.
Diving problems, you've got currents, tides, waves. We haven't been here before, we haven't been this deep. So.
One of those cylinders lasts a lot less than it does near the surface. One breath of air down there is equivalent to 6 breaths up here.
They've only got 25 minutes dive time, and it's going to take them 10 minutes just to get down there.
Yeah, okay to go. Yeah, roger that. Landing now. Just passing through 10 metres, over.
Marine life is concentrated at the very top of the ocean. The further down they descend, the tougher conditions become.
Visibility's not that good, over.
At only 60 feet down, the amount of light is only a quarter of that at the surface. The warm colors of the sun's rays have all given up, leaving a world shot through with the coldest blue. For plants, it signals the start of the death zone.
Echo, which way do you reckon it is? This direction. 30 metres.
Coral needs a water temperature above 72 degrees Fahrenheit to live. The deeper they go, the cooler it gets.
Hit the 40 metre mark. Halfway through our tank, it's still got a long way to go, over.
Finally, their target is within reach.
Just start to see the bottom now. It's the edge of the 50-metre feature. Oh, there's a clear outcrop. It's quite extensive.
The wall's almost vertical, look at that. Ticker is just going over the edge now.
Oh, here we go. Into the abyss.
At 150 feet down, they're entering a world where hard corals can't survive. Down here, there are only specialist soft corals, like these sea fans, the last frontier of life on the reef. The divers reach their target, a massive ridge, 190 feet down.
I'm just taking this sample. We're at this confirmed depth at 58 metres.
Here, the air they are breathing is under pressure, squeezed down so that there's more gas in every lungful.
I think we've got about 2 minutes left here, Tico.
They have to hope that the rock gives up before they do.
It's pretty hard stuff. Yeah, roger that. We'll just we'll take the sample here. Okay, I've got the sample.
With just minutes left, they must take the rock to the surface.
Let's have a look. What do we got?
For Jody, this is the moment of truth.
Hey, there we go. Whoa. Yep.
He's the first person to see what's hidden deep below the reef.
Yeah, it's definitely coral in there. You can see skeletal structure in here. Yeah, well, this is definitely coral.
And not just any coral. What they've brought back from the depths seems to defy nature. It's a species of coral that can only grow in shallow water. What could possibly explain this? The Earth's orbit is not stable. Over hundreds of thousands of years, tiny eccentricities in its path cause the planet to wobble on its axis. 18,000 years ago, it was tilted. Just 1 degree, but enough to tip the planet into cold clutches of chaos. An ice age. The polar ice caps started expanding aggressively, sucking up water into massive sheets of ice. Oceans dropped in every corner of the world, and the whole shallow sea on Australia's east coast disappeared. The reef was left high and dry, exposed to air and harsh sun. A trillion tiny creatures died in their own homes. For the coral, it was an apocalypse. When the Ice Age ended, the sea came back and submerged the dead reef. But what brought it back to life? The answer lies on the outer edge of the reef. Will Gadd is heading for an encounter with an invisible force of nature that waits in the same place all day, all night, all year. It's both a killer and a giver of life.
This is one of the most famous dive sites we have here. So we're at the top of Ribbon Reef number 10. You can see on the other side there, you can see the waves breaking. That's the open ocean.
Down here flows a monstrous current. It rips along the reef far faster than a human can swim. The only choice is to go with it. But what can kill a diver is also the lifeblood of this reef. It's called the East Australia Current, and it is the secret of how the Great Barrier Reef came back from the dead. Over 100 miles wide, 1,500 feet deep, and it ferries southward about 30 million tons of water per second, 2,000 times the flow of the Mississippi River. It carries a constant resupply of coral larvae from other reefs and other oceans, ready to repair any damage that the reef has suffered, however big. For thousands of years, this powerful current has regenerated the reef, but it cannot repair everything. Beneath the waves lie deeper scars. The largest coral reef on Earth is home to a dazzling diversity of marine species, some found nowhere else on the planet. It's a panorama of alien shapes and riotous color, where even the flamboyant mandarin fish can blend in. These coral gardens are home to armored reptiles and the softest of killers, the cone shell and the blue-ringed octopus. Delicate, graceful, and with enough venom to kill 24 people. While above glide giants, manta ray, and wandering minke whales. It is the most diverse ecosystem known to man, but this world used to be very different. Where fish now swim, birds once flew, and this whole forest of coral was once a tangle of trees and bushes. And this man can prove it. On a remote part of Australia's coast, geophysicist Thomas Stieglitz is looking for the last thing you'd expect to find in the ocean: fresh water.
We're on our way to a beach way up north. It's an Aboriginal community where people have told us that there's a lot of springs on the beach. Well, if there's water out there, where do you expect this water to come from? How does it actually get out there? I think somewhere around here there's supposed to be a pretty big one. I'm just trying to find it. It's actually quite a treacherous job. What we call quicksand actually on beaches. You can actually fall into that because it's such soft sand. Here it is. You got it, I think. A spring. And what's actually coming out of this is fresh water. you can drink. You can see the stuff bubbling out. This is what the traditional owners of this place call booyabindi, freshwater in the ocean.
The locals call them wonky holes. Freshwater springs in the middle of the sea.
And it's a really weird feeling when you're in the ocean here and you really think, oh, it means all the water here should be salty, and it's not.
But where does the fresh water come from? There are at least 200 wonky holes. The biggest are up to 60 feet across, and some can be found 20 miles out to sea. The clue to their origins lies in their location. They are found opposite the mouths of rivers, because hidden below the surface are underground rivers from an ancient past.
It's an evidence that at some point in the past, wherever we have the Great Barrier Reef nowadays, there was no water, it was all land.
Today, below the surface are channels carrying fresh water out to the sea. This hidden network was created during the last ice age. This whole place was transformed. The sea level dropped by 420 feet, leaving just the rivers flowing across this newly created land. They turned the seabed into a verdant landscape, where trees and shrubs flourished. This amazing transformation happened 6 or 7 times in the last 150,000 years alone. This is the Great Barrier Reef's alter ego, a world that has come and gone with every ice age. Surprisingly, annihilation has been good for this reef. Each time the sea rises up again, the coral builds a new layer on top of the rubble from the old reef, another level in this limestone city. So with every wipeout, the reef has ended up even bigger. But the wonky holes will never be completely covered up, because coral can't grow in fresh water. They'll remain an indelible reminder of the reef's past lives. But the origins of the reef lie even further back in time. And to understand them means cracking one of the Southern Hemisphere's greatest mysteries. It takes a unique set of circumstances to build something the size of the Great Barrier Reef, the most important of which is its perfect location. This entire reef sits in the tropics, and that means warm water and strong sunlight all year round. Without them, it simply could not grow to this colossal size. So how did the Great Barrier Reef end up here, perfectly located? Has it always been here? The geological evidence says no. Incredibly, it seems Australia started life about as far south as you can get, as part of Antarctica. Far too cold and far too dark for this epic reef. But the evidence of this incredible transformation isn't in the sea, it's found inland. Something so big, it transformed this place from a cold, dark world to a warm, tropical paradise. The answer is locked up in a series of mountains that stretch up Australia's eastern coast like a rocky backbone, called the Great Dividing Range. Geological super sleuth Kurt Nessel is on the hunt for the right mountain, one that holds the answers. But this mountain range is 2,000 miles long, so he's working with paraglider Will Gadd to cover more ground. Kurt is looking for this spectacular peak. It's called Mount Warning, and it has a violent past. Like all the mountains in this range, it used to be an active volcano.
looking at the core of the volcano, which is referred to as Mount Warning, that peak extends up to just a little over 1,100 meters.
But when it was active, the peak of this volcano was 6,000 feet high. Millions of years of wind and weather have worn it down. 100 miles north are the Glasshouse Mountains, all that's left of the interior of another huge volcano. To understand how the Great Barrier Reef began, they'll need samples from both mountain peaks. But this one's around 1,500 feet tall, not the easiest place to get to. With the wing under control, the quest can begin.
This is the mission here, Glasshouse Mountains.
Time has eroded this volcano beyond recognition. All that remains is the central core of lava that once lived within the volcano. It has cooled to form the sheer pinnacle of rock. Riddled with cracks, it has left handholds. Kurt is now on the less eroded slopes of Mount Warning. Slopes built from dust and ash from ancient eruptions. But that's not what he needs. He's looking for a sample of pristine lava. High on Mount Warning, he finds it.
The rock, as you can see, is very, very weathered. Most of the rock itself and the crystals that are in it are still fresh. And these are datable.
All lava has a chemical signature that tells scientists where it came from and when it was erupting. The higher up the old volcano, the more pristine the rocks will be. They are the last remaining evidence of the eruption, which created this volcano more than 23 million years ago. Only these rocks can reveal the full picture. 500 feet up, and Will's finally got the sample.
Now I gotta figure out a way to get down.
Analysis of the rocks from the Glasshouse Mountains and Mount Warning reveals something amazing. The lava in these two mountains, 100 miles apart, comes from the same place. How? The answer lies in an incredibly rare geological phenomenon. Deep below Australia, in the Earth's molten interior, is a hot spot, a mysterious area of liquid rock. It's hot enough to punch fresh lava all the way to the surface. But there's something very special about hot spots, something that allows them to reveal the story of Australia's past. Because hot spots don't move, but continents do, sliding right over them. This chain of mountains is a record of that movement. Tens of millions of years old, it proves that Australia has been moving northeast all the way from Antarctica at about 5 inches every year. And that makes it the fastest moving continent on the planet. 50 million years ago, Australia was near the South Pole. Cold water in the darkest of winters, conditions no coral could survive. But then it began to move north. $18 million years ago, it arrived in warm tropical waters. Only then could the world's greatest reef be born. Australia's epic journey may have created perfect conditions for coral, but it also put it in the line of fire of the most powerful storms on the planet. For thousands of years, the conditions that created the world's largest living thing have been in perfect balance. Even the elements here work in harmony to build the reef. Situated in the tropics, the sun hits the water at an angle so precise that almost no heat is reflected, but is absorbed into the warm, fertile waters. But not everything here is so benign. Some of nature's most brutal forces rage in this sea. From the west, cyclones gather strength as they race across the Pacific. But the reef has found a way of protecting itself. It's called the Great Barrier for a reason. It acts as a wave break, soaking up the power of storms and sheltering the coastline. It's Australia's first line of defense against the rages of the ocean, protecting not just the reef, but an entire continent. But how does something so fragile survive this onslaught? In fact, it doesn't just survive. Miraculously, it thrives. The waves here act like forest fires, sweeping through the reef, clearing away old growth. Dead and dying coral is removed, and space is made for new life to take hold. And wave action carries off sand and silt that could smother the corals. These destructive waves are as much a part of the reef's life cycle as the animals that inhabit it and the corals that make it. But out here, there's another miracle. 100 miles from the coast, in the midst of this huge flat sea, suddenly and without warning, land jumps up out of the blue. Out here, islands appear and disappear all the time. But what creates them? This magical process is easiest to see from the air. When waves hit the reef close to the surface, they smash its rocky skeleton, grinding it down into sand. The sand settles layer on layer until eventually, out of the sea emerges an island. Some of these new islands will be wiped off the map by cyclones. But with help from on high, islands can endure or even grow. On a highway with few rest stops, the embryonic island becomes a haven for long-distance travelers. These birds leave seeds in their droppings that grow into plants, binding the island's sand together, protecting it from the destruction of storms. An entire island paradise formed out of the sea, grown by the animals that live there. Today, the elements that support the reef are in fine balance: sun, wind, and waves. But it doesn't take much to tip the balance, plummeting this huge reef into disaster. It might happen sooner than you think. $18 million years ago, a series of remarkable events conspired to create the Great Barrier Reef. The migration of a continent, the might of an ocean, and the full power of the tropical sun. The result is a world that's as tough as it is beautiful. It's been through numerous catastrophes, and every time, it's bounced back. But the Great Barrier Reef now faces its biggest challenge: us. Over the last few decades, evidence of our influence on the reef has become all too real. Marine biologist Ove Gelberg is on the front line to protect it. Today, he's come to look for one of its greatest enemies, a single creature with the power to destroy the largest reef in the world.
Relatively small changes in the conditions can cause some species to literally explode. And one of those is the crown-of-thorn starfish.
This evil-looking animal grows up to 3 feet across, is covered in sharp, venomous spines, and its favorite food is coral. They can descend on the reef in their millions, swarming over it and eating it alive.
Like all starfish, it has the amazing ability to exude its stomach when it's feeding out of this hole here, digest the coral, and then soak up all the goodies, leaving essentially just the skeleton.
This starfish is capable of producing 6 million children every year. Normally, very few survive. But now man has tipped the odds in their favor. Fertilizers from inland farms have washed down from the rivers onto the reef. They make the perfect nutrient for the baby starfish, and their numbers go through the roof. The population can explode to 2,000 times its normal level. And they're incredibly hard to kill.
One of the early methods of getting rid of starfish was to cut them in half literally with a knife. But starfish have this amazing property where they regenerate.
Far from killing them, cutting these animals in half actually creates 2 of them. They have to be physically picked off the reef or injected with poison to control their numbers. Today, pollution levels have dropped, and so has the crown of thorns population. For now, anyhow. But there are worse things that the modern world is doing to the reef. Even the smallest change in climate upsets the natural order here. The turtles are already feeling it. Their eggs are very heat sensitive. With higher temperatures, fewer eggs are hatching, and the turtle population is in decline. In 40 years, there may be none left. And the coral reef itself is in grave danger because water temperature is a matter of life and death. A change of just 1 or 2 degrees can wipe it out. But scientists are discovering that coral isn't totally defenseless. It has a protection mechanism that defies belief. If temperatures get too hot, coral responds by trying to change the weather. It exudes an invisible chemical that floats above the water and encourages clouds to form. providing shade on the hottest days. It's an astounding mechanism, but it looks like it's being overwhelmed. Recently, the coral has been telling us that it's had enough. Because when it overheats, it self-destructs, expelling the algae that live with them. They turn deathly pale, a process known as bleaching. It's a desperate measure, will eventually kill them. So Ove is constantly monitoring the reef to see which corals are at risk.
Now, there's no point in using this instrument on these corals because they're dead.
A temperature rise of just 2 degrees would wipe out almost all the coral on the Great Barrier Reef, a change that could happen within the next 60 years. No coral, no fish, no life.
We've already committed ourselves through the CO2 that we've put into the atmosphere to some changes on the Great Barrier Reef. Now, what happens next is really up to us.
And it's not the only effect of global warming. As carbon dioxide levels rise in the atmosphere, acidity levels rise in the ocean, dissolving the living coral away from the rocks. If it continues, the Great Barrier Reef will perish. We may be the last generation to see this incredible natural wonder as it is today. But the one thing that the past has taught us is that the reef always bounces back. The question is, will we be around to see it?